The next question is letter X. Letter X, acidified potassium permanganate is added to a solution of sodium nitrite. And we're being asked about the oxidation half reaction for mass and charge. We're getting an indication that this is a redox reaction, and I'm noticing a key word that said acidified. This is coming out of chapter 20 when we first learned how to balance redox reactions by the half reaction method, where we would do a Leo and then a Gur and then add them together, knowing that we balance the hydrogens with water and so forth. So let's take a peek at where we're beginning. With letter X, potassium permanganate. Now potassium permanganate is written as KMnO4. But I'm going to choose to just start eliminating the spectator potassium. And remember that any first family ion is always a spectator. So let's just think about MnO4 negative. And the half reaction it would follow is going on to produce the most common ion, the manganese plus 2 ion. So there's the first half reaction. Secondly, it said sodium nitrite. Sodium nitrite is written as NaNO2. And again, thinking about eliminating the first family ions. So now we're just considering the nitrite ion. NO2 negative. And thinking through its most common polyatomic form is the nitrate ion, NO3 negative 1. So these are our two half reactions that we'll begin considering, and we'll work through and balance both of them by mass and by charge, and then add them back together. So in the first half reaction, I notice that the MNs are balanced. I need to add some water to balance the oxygen, so I'll add 4 H2Os. Come back to the left-hand side and we'll add on 8 hydrogen ions. Now the net charge on the left side is a +7, and on the right side it is a +2. They don't both have to be 0, but they do have to balance by charge. We'll get the left side to come down to a +2 by adding 5 electrons. Now let's consider the second half reaction. In the second half reaction, I have NO2 going to NO3. The oxygens need to be balanced, and we'll do so by adding 1 water molecule over to the left-hand side, making me have to add 2 hydrogen ions to the right-hand side. Now let's consider charges. If I have a net -1 on the left and a net +2 over here, -1, -1, these two will just balance each other. We'll need to bring 2 electrons to the right-hand side to balance the second half reaction. Now Leo must equal Gur, so if 5 electrons are being gained, we must have the same number being lost. So we'll need to distribute a 2 from the first equation and a 5 through the second equation, and we'll add them back at the same time. 10 electrons plus 16 hydrogen ions plus 2 MnO4 negatives. Continuing on the left-hand side, we have 5 waters and 5 nitrite ions. On the right-hand side, we have 2 Mn plus 2s and 8 waters, plus we have 5 nitrate ions, 10 hydrogens, and 10 electrons. Let's see what we can simplify. The 10 electrons are gone. Thinking about hydrogens, we have 16 on the left and 10 on the right, so that will simplify to a net of 6 hydrogens on the left. The waters, we can eliminate 5 from the left, leaving us a remainder of 3 on the right, and I believe we have it. 6 hydrogen ions plus 2 permanganate ions plus 5 nitrite ions, forming 2 manganese plus 2 ions, 3 waters, and 5 nitrate ions. So there is the complete balanced redox reaction. Remember that the question asked us for the balanced oxidation half reaction. Now, oxidation is loss of electrons. So if I go back up and just simply show my loss of electrons half reaction, I have written in terms of a balanced equation, in terms of the number of atoms, and in terms of the charge. So this right here would be the answer to our question, the half reaction representing the loss of electrons, oxidation.